Welcome to the video for skill number 57. I can use long division and synthetic division to divide polynomials. We will start our notes on page 57A, Polynomial Division. Long ago we learned about long division in elementary school, and in doing so we learned about key terms, the dividend, divisor, quotient, and remainder. Polynomial division does the same thing, where you have a dividend on top of the fraction and a divisor on the bottom of the fraction. And when you write it out in the long division method, the dividend goes under the divide sign and the divisor goes in front of it. Your quotient will wind up being on top, and your remainder is shown of one of two ways, either down here at the bottom, or if you rewrite the whole polynomial, which I'll ask you to do, you can see it as a fraction at the very end of the polynomial. I don't want you to focus too much on how this works right now because I will explain it on the next page. On page 57B, I show one example, and this example is actually far more complex than any problem that I will give you on a test. However, I have found that students follow the method better when shown a slightly more difficult problem, because you can see the pattern that occurs in solving the problem. The problem given is divide by using long division 6x to the 6th plus 4x to the 5th minus 2x to the 3rd plus 1 divided by x squared minus x plus 2. The process you want to carry out is put your dividend underneath the divide sign and make sure you include placeholders if there are any. If you forget to include placeholders, you will definitely make a mistake, and then you put your divisor out front. Step 2 is divide as you would with numbers, and I'm going to walk you through this process. I'll zoom in on it and discuss each step as we move along. Alright, so I've zoomed in on the division problem, the long division, and when we're dividing as you would with numbers, it's slightly different for polynomials, but we want to ask ourselves, how many times will x squared, the leading term here, go into the leading term here, 6x to the 6th? I know that there will wind up being 6x to the 4th as an answer, because x squared times 6x to the 4th equals 6x to the 6th. Once I know that, I can write that number down, and I write it directly above. And then from there, what I want to do is I want to multiply 6x to the 4th times this trinomial. So 6x to the 4th times x squared minus x plus 2. And I'll write that value, whatever it is, down here. 6x to the 4th times x squared is 6x to the 6th. 6x to the 4th times negative x is negative 6x to the 5th. And then finally, 6x to the 4th times 2 is 12x to the 4th. At this point in long division, you can subtract one line from the other. So we take what we multiplied and we subtract it from the line above. So 6x to the 6th minus 6x to the 6th is 0. 4x to the 5th minus negative 6x to the 5th is positive 10x to the 5th. 0 minus 12 is negative 12x to the 4th. Notice all those powers stack. And then beyond that, everything you can just carry down. the negative 2x to the third gets carried down, 0x squared carries down, 0x carries down, and 1 carries down. A brief repeat of the problem. I took x squared and I asked myself how many times will it go into 6x to the sixth, and it goes in 6x to the fourth times. I took 6x to the fourth and I multiplied it by the whole trinomial, writing the resulting answer here, and then I subtracted the resulting answer from my dividend, getting 10x to the fifth minus 12x, etc., etc. At this point, I repeat the process, and I'll show that below. Okay, so I had this value, and I have to repeat the process with x to the squared minus x plus 2. So how many times does x squared go into 10x to the fifth? X squared times 10x to the third is 10x to the fifth. So I take this value, 10x to the third, and I multiply it by the trinomial. 10x to the third times x squared is 10x to the fifth. 10x to the third minus x becomes negative 10x to the fourth, and 10x to the third times 2 becomes positive 20x to the third. And then I take that equation and I subtract it from the above one. 10x to the fifth minus 10x to the fifth is 0. Negative 12 minus negative 10 is negative 2x to the fourth. And negative 2x to the third minus positive 20x to the third is negative 22x to the third. And then the values carry down, and carry down. And we repeat the process. This time we have this value that we are going into. How many times does x squared go into negative 2x to the fourth? It goes in negative 2x squared times. Negative 2x squared times the trinomial is this. We subtract, and we get this value here, carrying the values down. And we repeat the process again. Negative 24x times x squared is negative 24x to the third. Those two will cancel. And you repeat negative 24x times negative x is positive 24x squared. Negative 24x times 2 is negative 48x. You subtract, and you get this answer. And you repeat, and eventually you get to a point where you can no longer factor a value in. X squared, oops, the value x squared can't be multiplied by anything to get 28x. At least not any polynomial. So x squared does not go in there, so this becomes our remainder. And we can write the remainder over the divisor as the final piece to the polynomial. Once again, I want to repeat that this problem was far longer and larger than any problem that I will give on the skill test. At this point, I want you to take a look back at the first page, 57A. The example at the bottom of page 57A is more on par with the homework and what is done on skill tests. So we wanted to take the divisor of 2x squared plus 7x plus 7 and divide it by x plus 2. So we write the dividend under the divide sign, the divisor outside. X times 2x is 2x squared, so we multiply it by both pieces to get this. Subtract one from the other. 7 minus 4 is 3x. Carry the 7 down, and you get 3x plus 7. 3 times x is 3x. 3 times 2 is 6. Subtract them and you get a remainder of 1. So our answer is 2x plus 3 plus the remainder of 1, or 1 divided by x plus 2. For those that don't enjoy long division, there's actually a method of dividing by binomials called synthetic division. Well, actually, synthetic division can be used with trinomials as well, but I'll only do synthetic division with binomials in class. We'll continue that on page 57C with our notes. So we're going to do the same problem that I just spoke about, the smaller one, with synthetic division. And synthetic division is actually, in my opinion, much cleaner and much easier way to solve division, particularly for binomials. So we were tackling the problem of 2x squared plus 7x plus 7 divided by x plus 2. And what we want to do is, step 1 is to set it up using synthetic division. So x plus 2 is really x minus negative 2. And what we'll do is we'll draw a box with negative 2 in it. The next part of synthetic setup is write the coefficients. So we have 2, 7, 7. So 2, 7, 7. It's pulled from the dividend. Underneath that, you will create a bar with a little line down there. And then you use synthetic division to divide. So the first step of synthetic division is to carry your first number down, so 2 moves below and becomes a 2 underneath the line. From there, you multiply 2 times negative 2 and put it up where this is. 2 times negative 2 is negative 4. And then we add those to 7 plus negative 4 is positive 3. And then we repeat again. 3 times negative 2 is negative 6. And then we add them. 7 plus negative 6 is positive 1. At this point, we are done, and we can write the answer as a polynomial. So the 3 carries down, the 2 becomes 2x, and our remainder is 1 over x plus 2. Synthetic division confirmed what we saw earlier with the long division. On the next page, I'll show you an example of synthetic division with a slightly more difficult problem, but you'll see that it's just as easy to do. In this problem, we have a longer dividend, and our divisor is still a binomial. So the x plus 3, we know that 3 becomes negative when we put it in the box, and then we set up all the coefficients. And remember, your dividend has to be in standard form, so our coefficients are 2, 4, negative 1. We're missing an x squared term, so we have to write 0 in, and then 2, 1. Skip a line, draw the line underneath it, and the last term gets a line right there. And then we go through our process. Our process, the 2 is moved to the bottom. 2 times negative 3 is negative 6. We add 4 and negative 6, and we get negative 2. Negative 2 times negative 3 is positive 6. Add negative 1 and 6, and we get positive 5. 5 times negative 3 is negative 15. We add those two terms. 0 plus negative 15 is negative 15. Negative 15 times negative 3 is 45. We add 2 plus 45 and we get 47. 47 times negative 3 is negative 141. And we add those two to get negative 140. And then we can just write that out as our answer. 47, negative 15x, 5x squared, negative 2x to the third, 2x to the fourth. And our remainder is negative 140 over x plus 3. Finally, synthetic division can be used to evaluate functions as well. This skill is good for rather long functions or a way to check the value of functions. So now we have two ways to do it, and I'll show you that on the next page. On the skill test, you'll be asked to use synthetic substitution to evaluate a function. So the way it shows up is evaluate f of x equals 5x to the third plus 2x squared minus 1 at x equals 6. So if you're evaluating it at 6, you plug 6 into the box, and then you write down your coefficients in standard form. 5, 2, we're missing a 0x, so we get a 0, and then negative 1. And then we carry out synthetic division. Bring the 5 down. 5 times 6 is 30. 30 plus 2 is 32. 32 times 6 is 192. 0 plus 192 is 192. 192 times 6 is 1152. And negative 1 plus that is 1151. So that means if we were to plug 6 in to this function, we would get 1151 as an answer. It happens to be our remainder. And just below, I've shown a check of that. So we plug 6 in, and we get 5 times 6 to the third, which is 5 times 2, 16, which is 1080. 2 times 6 squared is 2 times 36, which is 72, and then minus 1. Add those three numbers, and we get 1151 as an answer. On skill 57, there are three key things we need to be able to do for the skill test. One is long division of polynomials. 2 is synthetic division of polynomials. And then finally, synthetic substitution to evaluate polynomials. Thank you.